Hello, today we are at Hanze Makerspace and we're going to explore the topic of educational robotics. Now we're going to meet with Felipe, a researcher and teacher who specializes in this field, and we're going to participate in the robotics lab. Let's go.
Yeah, my name is Felipe Martins. I work here at Hanze University of Applied Science, teaching robotics mainly, and industrial robotics, and projects related to robotics, but also electronics and microcontrollers. And I'm also involved with the robotics club, which is called HARPA, and it's hosted here at the Makerspace, the Hanze Makerspace. I've been involved with robotics for a long time, since 2010. And for about 10 years I've worked with robotics competitions. Specifically the Brazilian competitions and the RoboCup competitions as well. Those competitions I was involved with, they are all focusing on educational robotics, so focusing on for primary and mainly secondary education. So students up until 19 years old. During this process they actually dive into concepts of mathematics, physics, electronics, programming that they would not touch if they were just following the regular curriculum. And on top of that, I think robotics, the most important thing related to education is that breaks down all those walls between the courses. And the students start to see the applications of one course and the other, but mixing them up. I think that the actual building robot project is already a technique, right? That's the technique. It's having the task of building a robot with some requirements. In many cases, it's very open project, right? So having the students working on a task that seems to be easy at start, then they find it very motivating because it's nice building a robot, and they like that, of course. They can divide the tasks, and then maybe one student works more in the mechanical, other more in programming, whatever they like. And if you like doing something and it's something cool, then you are motivated, so you work hard. I think in simple terms, it's a computer that interacts with the real world with sensors and actuators. That's the most basic definition, I would say. But there are many different definitions of robots, and it's difficult to get one definition that everybody agrees on, actually. In general terms, you expect a robot to have some sort of autonomy to achieve a goal. So it's a goal-achieving machine. Most of the students are working on robots with wheels that can move around. There were a couple of students working with drones as well, because you can make a drone autonomous and then it's a flying robot. And with mobile robots, you can have mobile robots with wheels, but also with legs and other types of locomotions. There are many different types of wheels as well that do different things in different conditions. So some will work much better indoors, but not outdoors. And others, like this agricultural robot, they will work much nice in the field with dirt and stuff. But if you put them here, then they will have too much grip. The robot cannot control itself nicely, and they will demand a lot of energy as well. So that depends on the application. But the students mostly are busy with mobile robots also because they are very simple to build. There are many cases that we can use machine learning robots. I had a student a couple of years ago working on a specific type of machine learning called reinforcement learning to teach a robot how to pick parts. And that, I think, is the key for when you get machine learning together with robots, you get a very adaptable, potentially, robot that can perform well in situations it was never programmed explicitly to do. The impact on daily life is already here, actually. We don't see explicitly a lot of robots, maybe. Our lives are very much dependent on robots because there are so many robots in industry nowadays that you can only buy a car the price that it is because of robots. There are the electronics that you are holding on your hands, it's only possible because of robots as well. It's going to become much more important and more visible to us the more the robots become more adaptable. And this is likely to happen with the integration with machine learning, for example. And then we're going to get robots in lots of situations that we have less and less control of. But I think the biggest impact will be in specific fields, which is, for instance, for healthcare in developed countries, people are getting old, and you have less and less young people, and more need for care of old people. Or you build robots to do that. We have the need to increase productivity in food production, for example. At the same time, we have less and less people that want to work in agriculture. How do we solve this problem? Only with machines. This robot will help some other robots as well. So I think that robots will have a huge impact if we can make it properly, of course, in those areas specifically. Because we are going to need people. So it's not only about taking away jobs from people, that's the problem indeed, but that's a different problem. But actually we are going to need workforce that we don't have at the moment available, I think.